Okay, so this is a half sheet that you are going to fill out before we move on in our notes here. Um, so this is the formula for our inequality word problems. It's going to be the dependent variable times the variable plus the independent variable. You pick an inequality, and then you're going to have the total. So this is going to look more like it's going to be numbers here. So it'll be like 14, that's our dependent variable. X is our variable, plus 5 is greater than or equal to 50. That's what it's going to look like. Okay, so don't write that down. I'm just giving you an idea of what it's going to look like. So first we need to remember what a dependent variable and an independent variable is. So a dependent variable, the way that you're going to know what the dependent variable is you're going to see the word each. So if it's a dollar each, that's going to tell us that that's our dependent variable. The variable is the unknown value that we are trying to find. Are trying to find. The independent variable is the variable that happens just once. So if you see a number that's like they paid $10 to get in and they're not going to pay $10 again, so it happens once, we're going to call it, we're going to say not going to change, not going to change. So far we have 3 pieces of information we need to find in our problem. The fourth piece we need to find is we need to select which inequality from this set of inequalities. Select inequality using our word bank. All those keywords we had, like at least or minimum or maximum. And then the last bit, which is the easiest part, is the total. Well, we don't need to say what that is. So if we see a total that where he's like, Bernice has $50 to spend, that would be our total. It's normally the biggest number. Okay. So this is our formula. So the way I'm going to abbreviate it is like this. It's going to be DV, that stands for dependent variable, times the variable plus IV, which is independent variable. Then I'm going to put all the signs. You're only going to pick one, but I'm going to put them all there just so, and then total. I know this means nothing right now, but once we get into it, you're going to refer back to this to help you figure out what the problems are. So here we go. We're just going to dive right in. All right. So the first level 3 problem we have, I'm just going to read through it once. So Daniel had $25 to spend at the fair. If the admission to the fair is $4 and the rides cost $1.50 each, what is the greatest number of rides that Daniel can go on? So first thing we're going to do is we're going to write out that formula. So we have dependent variable times the variable plus the independent variable, and then all these inequality signs and the total. Okay, that's what we're plugging in. Numbers we have $25. He has a total of $25 to spend at the fair. So total we know is going to be 25. Okay. If the admission to the fair is $4 and the rides cost $1.50 each, so admission is going to happen one time. Okay, once you go in, that's going to be your admission. So that's our one-time fee or our independent variable, our IV. And remember that keyword each tells us that $1.50 is our dependent variable. So we have $1.50. What we're trying to find is our variable. We are trying to find the greatest number of rides that Daniel can go on. So the variable is number of rides. So I'm going to call it R. So we have 150R plus 4 is, now we got to figure out the sign, the inequality. So the inequality has some keywords here. We look here, we have what is the greatest number of rides that he can go on. So is the number of rides, does it have to be less than 25? The amount of, so this over here, sorry, is the amount of money he's going to spend. Okay. He has $25 to spend. So he needs to come out at a value that's less than or equal to, I'm going to draw a little arrow here. He needs to come out with a value that's less than or equal to 25. Because he only has 25. So he can only spend equal to $25 or less than $25. Okay? So that's what we're doing. I think we're just going to start by writing it, and then we can go back and solve it. Because the hard part is writing it. All right, so moving on to the next one. I'm going to try to use different colors here. So Florencia has at most $60 to spend on clothes. So let's do our DV, our V, and our IV. I'm just going to put one sign and our total. Okay. So Florencia has at most $60 to spend on clothes. She wants to buy a pair of jeans for $22 and spend the rest on t-shirts. Each t-shirt costs $8. Write an inequality to determine the number of shirts that she can purchase. So first off, we have she has at most $60. So that's our total. That's how much she can spend. Change our colors here. So she can spend $60. So it also tells us it's at most $60. So it's got to be less than or equal to. At most. So go back up to where they have those keywords, and at most is right here. At most. That's less than or equal to. And then we go back down here. All right. She wants to buy a pair of, I'm right here. She wants to buy a pair of jeans for $22 and spend the rest on shirts. So she wants to buy a pair of jeans just once, just one pair of jeans for $22. And the rest she wants to spend on shirts. So our independent variable, the thing that's going to happen one time, is 22. Each shirt costs $8. See that keyword each tells us that $8 is our D. And then our variable is how many shirts can she buy? That's what we want to know. So I'm going to put S. So 8S plus 22 is less than or equal to 60. We're not going to solve just yet. Actually, we're not going to solve it all in this video. We're just going to write them. If we can write them, I will be so happy. So happy. Okay, number 27. Leah needs at least $240 to buy new headphones. She's already saved $30. She earns $14 per car that she washes. What is the least number of cars that she can wash to buy the headphones? So let's do our DV times V. Did I do that on the last one? I don't even remember. Yeah. Plus IV. I'm just going to put less greater than because I don't want to write all the signs. And then total. So she needs at least $240. So let's go ahead and write our inequality. What's at least? At least, where are we at? At least, here we go. So that's going to be greater than or equal to. Greater than or equal to. So it's going to be greater than or equal to 240. She's already saved $30. So that's going to be right here. 30 is our independent variable. It's not going to change. She earns $14 per car that she washes. Okay, that's one thing we need to include in our notes. So let's go back to that half sheet. I said the keyword each. Let's add per. If we see $1 per pair or $1 per something, we need to write that down because that tells us that's the dependent variable. Oops, wrong one. All right, so $14 per tells us that's the dependent variable. The variable is the number of cars she can wash to buy the headphones. Okay? So number of cars she can wash to buy the headphones. So we're going to put C for our variable cars. That's what we're looking for. And I'm going to call it good on this one. Actually, I'll read one more and see if you can at least set it up. So 28. Sylvie set a goal of saving at least $200 in a savings account. So we see at least $200. So what is at least? It was in the last one, I'm pretty sure. At least tells us to do greater than or equal to. So greater than or equal to 200. She currently has $60 in the account. So $60 is our one-time, uh, our independent variable. Oh man, I forgot to put all this stuff. Shucks. Let's try that again. So we do dv, dependent variable, times variable, plus iv is greater than or equal to total. Okay, so at least $200. That tells us we are going to put greater than or equal to 200 because at least. It's the same one as last time, at least. She currently has $60 in her account. So 60 is going to be our independent variable. It's not going to change. If she invests $5 of her weekly allowance per week, so we got $5 per week. So remember, per tells us that's the DV. 5. How many weeks will it take her to reach her goal? So we want to know how many weeks. So that's our variable. Weeks. 5 times weeks plus 60 is greater than or equal to 200. All right, so once you have that down, I want you guys to solve these 3 equations. Actually, solve these 4 equations and tell me what you come out with.